E1 and another source of EMF E2 or epsilon 2. Consider a potentiometer, and this is the cell whose EMF EMF has to be measured compared with another one, and this is another cell. Connect this positive terminal to positive, its positive also connected here, this is very important, and its positive also connected here. Positive terminals of all these three cells are connected to point A, and this is connected to plug K1, this is connected to plug K2, both of them are connected together, and this is connected to a galvanometer like this, and another terminal is connected to this jog key. So now close K1, and also here it is closed. K2 is open. If K2 is open, no current flows. It means it is not activated. Only this one is activated. Due to this current flows, therefore it is showing deflection. And as this pointer is moved, look here, like this, galvanometer shows zero deflection. At this point, current becomes zero. This is known as balancing. Now, the piece of wire between AC acts as a source of EMF, whose EMF is equal to EMF of this cell. Therefore, as potential at this point is equal to potential at this point, no current flows. So this is said to be balanced. This balancing length AC is taken as L1. Now, according to principle, E1 is proportional to L1. Its EMF is proportional to L1. So E1 is equal to pi into L1. Now consider this equation as 1. So now open this K1 and close K2. Now this is inactivated, this is activated. The current flows here due to this second cell. So look here, this is showing some deflection, means the balancing length of this one may be greater than L1. Let us move this one like this, and somewhere here we got balancing length. So this is L2 is balancing length of this E2. So this piece of that is AD, piece of wire AD has EMF equal to EMF of this one, therefore it is balanced. E2 is proportional to L2. So E2 is equal to pi into L2. So take this equation as E2. Now dividing E1 and E2, we get E1 divided by E2 is equal to pi L1 divided by pi L2. Pi get cancelled. Therefore E1 by E2 is equal to L1 by L2. Using this equation, we can compare E1 and E2. E1 is to E2 is equal to L1 is to L2. So this is how potentiometer can be used to compare the EMF of two cells. Now let us discuss the second application of potentiometer, that is to determine internal resistance of a cell. So consider potentiometer with this battery. This is plug K1 rheostat. Connect a cell of EMF E1 to this one. Look here, positive terminal of the cell is connected to A, and a resistance box along with a plug key is connected in parallel with this one like this. So this is RB, this is K2, this is K1, this is K2. So now this combination, look here, this combination is connected to this galvanometer, and galvanometer is connected to jog key like this. So now let us close this K1 like this, and here K2 is kept open. K2 is kept open means this resistance box is inactivated, it has no effect. So as this is open, now this cell is said to be in open circuit. Open circuited cell is connected here, therefore this EMF E1 acts. Due to this one, current flows here. So as the current flows, deflection is towards the right. Now let us move this jog key to the right so that it becomes 0. It means the piece of wire between AC acts as a source of EMF. Its EMF is equal to EMF of this one, therefore it is balanced. Therefore this is 0 deflection. So this L1 depends on E1. E1 is proportional to L1. So that is E1 is equal to pi into L1. Take it as equation 1. Now let us close this K2, K1 and also K2. So now this cell is in closed circuit because it is connected to external resistance. When it is in closed circuit, now the current is due to terminal potential difference. So that is V. So terminal potential difference is less than EMF. Therefore, this jockey has to be moved left like this. So it is moved. Here we get balancing length. So let it be D and length L2. So terminal potential difference of this one is V. V is equal to pi into L2. This V is proportional to L2. V is equal to pi into L2. Take this equation as 2. Now dividing equation 1 by 2. Equation 1 is E1. This is V. Pi L1 divided by pi L2. It is like this. Pi get cancelled. Therefore E1 by V is equal to L1 by L2. Take it as equation 3. So now we know for a cell EMF E is equal to I into R plus R. R is external resistance. Small r is internal resistance of this cell. Current I is flowing through this circuit. So now V is equal to I into R. This is according to Ohm's law. This is terminal potential difference. Dividing these equations, we get E1 by V is equal to I into R plus R divided by IR. I get cancelled and therefore it is R plus R by R. Now look at these two equations. Here E1 by V, here E1 by V. Left hand sides are equal. Therefore compare right hand sides. L1 by L2 is equal to R plus R by R. That is L1 by L2 is equal to R plus R by R. Take this one this side and this one this side. It is like this. And now R by R plus R by capital R is equal to L1 by L2. R get cancelled. Therefore R by R is 1. R by R. So now take this equation here. That is 1 plus so much. So take this one this side. R by R is equal to L1 by L2 minus 1. Cross multiply. R is equal to R into L1 by L2 minus 1. So from this equation we can determine R, that is R is internal resistance. Capital R is resistance of resistance opened in the box, that is external resistance. L1 and L2 are balancing lengths. Like this, using potentiometer we can determine internal resistance of the cell. The formula used to calculate internal resistance is this one. So this is about potentiometer. Potentiometer has the advantage that it draws no current from the voltage source being measured. As such, it is unaffected by internal resistance of the source, and therefore we can measure accurately the EMF of the cell. So this is about potentiometer. If you like this animation, explanation, and the way, you subscribe my channel PM Physics Legends and like it, share it with your friends and students. Thank you.